Okay, we finally made it out of chapter 4, and we're in chapter 5, which is on analytic trig. So the word analytic, of course, means analyze, and we're going to start with identities and how they work and how the trig relationships are related to each other and how they are true in these relationships. So the first example, find sine theta and cosine theta if you know tangent of theta is 3/4 and sine of theta is greater than 0. Now the reason we have to have the sine of theta is greater than 0, so that puts us at the right angle, because otherwise you could have a negative over a negative to make the positive 3/4, or you could have two positives. By saying that sine has to be positive, that forces us, with tangent being positive, to be in quadrant 1. So that's where we know we are. We're in quadrant 1. So all of our angles are going to be positive. All our values are going to be positive. So now we just can't simply say, oh, tangent is sine over cosine. So sine is 3 and cosine is 4. What we have to do is use things that we know that are true to work backwards for that. So that's why we call them identities, because they are things where both sides of the equation are true. So let's start with a tangent identity that is true, and that would be our Pythagorean identity. So our Pythagorean identity with tangent is 1 plus tangent squared of theta equals secant squared theta. Now that is a truth because it's an identity. So we can fill in what we have, which is tangent squared. And we can solve for secant squared theta. So 1 plus 9/16 equals secant squared. And of course, 1 is 16/16. And we get 25/16 is secant squared theta. And again, since we're talking just with positive, what we can do is just take the square root of both sides, and we get that 5/4 is secant theta. Now how does that help us, since we're asked to find cosine and sine? Well, another identity that we have is that 1 over secant theta is cosine theta, and that's our reciprocal identity. So we just have to take the reciprocal of secant theta. So that means cosine theta is going to be 4/5. So we have half of our answer, one of our two answers so far. Now we can use that and another identity to find sine of theta. So we can use another Pythagorean identity, which is sine squared theta plus cosine squared theta equals 1. And again, we can do just like we did with our Pythagorean identity with tangent, is we can substitute for cosine theta and solve for sine theta. So we'll substitute in 4/5 and square that. So we get sine squared theta plus 16/25 equals 1. So sine squared theta is going to be 1 minus 16/25. So sine squared theta is going to be 25/25 minus 16/25. So we get sine squared theta is 9/25. And again, just like with cosine theta and the fact that we're in the first quadrant, we can just take the positive root of that, and we get that sine theta equals 3/5. And that's the answer for sine theta. So now we have found cosine and sine theta using some basic identities.